Okay, now let's try the p-value approach. So the p-value approach is going to be the same as the previous hypothesis test in the concept that the p-value is the area beyond the test statistics. Okay, and so the larger the p-value means that our observation is not rare. Remember, a p-value represents the probability that we will observe a more extreme value if we go out and collect a sample again. Right? And so our test statistic, now recall our test statistic is n minus 1 s squared over sigma square, and in our previous page, right, we've calculated our test statistic to be 12.6, and so our goal is our p-value is going to be, well, here we have a chi-square distribution and here is 12.6. Now what we're interested in is in this area, so this tail here is going to be the p-value, right? And if this p-value is small, that means our observation is rare relative to our hypothesis. And if that's small enough, right, then we will reject. Okay, and so let's go ahead and calculate that p-value using our app. Okay, so I need to give an alpha. We need an alpha. So previously our alpha was 0.10. So let's go ahead and use the same alpha here. And then we also need a degree of freedom. All right, our degree of freedom equals to 9. Okay, and so here we have degree of freedom 9, and then let's go ahead and put in 12.6. That's our test statistics. We want the right tail, and then here we go. So our p-value is 0.1816. Okay, all right, and so now we can see that our p-value, it is greater than alpha. It is greater than alpha. 0.1816 is greater than 0.10. That means our observation. Now it's important to remind ourselves, what do we mean by observation? What do we observe? We observe, right, in our study, we observe a sample variance of 0.7. The question is this an extreme value, right? Is this extreme? And when we say extreme, we're comparing it to the null hypothesis of 0.5. So just look on the previous page, and so we're saying that, well, it is large. It is larger than 0.5. However, at a probability of 0.18, it is not small enough. Right, it's not small enough. So therefore, we will accept, or we say we fail to reject the null hypothesis. Okay.